students, in this session we will discuss moment area method. In previous two sessions we discussed introduction of moment area method and we solved two numericals. Now in this session we will solve numerical to calculate slope and deflection of cantilever beam which is carrying uniformly distributed load and point load both. So let's solve one numerical. In this numerical, we need to calculate slope and deflection at free end of the cantilever beam using moment area method. Value of Ixx, which is given 5 into 10 raised to 8 mm raised to 4, and value of capital E is 2 into 10 raised to 5 Newton per mm square. Here, the cantilever beam AB is given. The beam carries 140 kN point load at point B, which is 4 meter away from point A. The beam carries UDL of 20 kN per meter of total span 2 meter between point C to B. The beam has free end at point B and fixed support at point A. Now, here, first of all, whenever the beam carries UDL, then we need to convert it into equivalent beam. So, between point A to C, we add one downward acting UDL of 20 kN per meter, and in section A to C, we also add one upward acting 20 kN per meter UDL. Ultimately, result of this, both the load will be 0. But for calculation purpose, we are adding this 20 kN per meter to opposite acting UDL between point A to C. Now, let's calculate moment. And for calculation of moment, first of all, we will calculate moment by considering the beam only carries this 40 kN point load. Means there is no UDL on this beam. Okay. Then we know that moment at free end B is 0. So MB will be 0. Now MC. So this 40 kN load will generate clockwise moment above point C. And we are calculating moment from left hand side. So we will consider clockwise moment as negative. So moment of this 40 kN load about point C is equal to 40 into 2 meter, where 2 is distance between line of action of this 40 kN load from point C. Similarly, this 40 kN load will generate clockwise moment about point A, which is equal to 40 into 4 meter. Here 4 meter is the distance between line of action of this 40 kN load from point A. So MA is minus 160 kN into meter. Okay, so here we calculated moment by considering that the beam carries only this 40 kN load. Now, here is M upon EI diagram for point load only. Means here is the M upon EI diagram by considering that the beam carries only 40 kN load. So moment at B is 0. Now moment at C is 80 kN into meter. So M upon EI will be 80 upon EI. Similarly, moment at A is 160 kN into meter. So M upon EI will be 160 upon EI. Okay. Now in between point B and C and A, there is no load. Okay. That's why the bending moment line will be straight inclined line. Now in this step, we will consider only the beam carries only downward acting UDL and there is no other load on this cantilever beam. So at free end moment is 0. Now at point C, UDL, which is downward acting between point B and C, will generate clockwise moment, and the moment generated is clockwise, so we will consider it negative. So moment of this UDL about point C is 20 into 2, which is total load of UDL, into 2 by 2. 2 by 2 is the distance between line of action of this UDL from point C. So I am getting MC is equal to minus 40 kN into meter. Now let's calculate moment at point A. So here, this downward acting UDL between point A to B will generate clockwise movement about point A. So it will be minus 20 into 4. Here we are considering UDL between point A to B. So length of UDL will be 4 meters. So total load of UDL about point A is 20 into 4, and line of action of this UDL about point A will be at a distance 4 by 2. Okay, so I am getting MA is equal to minus 160 kilonewton into meter. Now let's draw M upon EI diagram for downward UDL only. Okay, so at C moment is minus 40. So M upon EI will be 40 upon EI. Similarly, moment at A is minus 160. So M upon EI will be 160 upon EI. Now, in between point B and C and A, there is a UDL. So, bending moment diagram will be parabola. So, this is M upon EI diagram for downward acting UDL only. Now, in this step, we will calculate moment for this upward UDL only. Means here we assume that the beam carries only one UDL between point A to C, which is acting in upward direction, and there are no other load on this cantilever beam. So moment at B will be 0. In between point B and C there is no load. So moment at C will also be 0. Now this upward acting UDL will generate anti-clockwise moment about point A, and we are calculating moment from left hand side. So we consider all anti-clockwise moment as positive. So moment of this 20 kilonewton upward acting UDL about point A is equal to 20 into 2. It is total load of this UDL into 2 by 2. 2 by 2 is the distance between line of action of this upward acting UDL from point A. So I am getting MA is equal to plus 40 kilonewton into meter. Okay. Now let's draw M upon EI diagram. So here in between point B and C there is no load. So at point B moment is 0. At point C moment is 0. So M upon EI will be 0. Now at point A moment is plus 40. So here this M upon EI diagram will be positive and it is 40 upon EI. In between point A and C there is UDL. So bending moment diagram will be parabola. Okay. Now let's move to next step. Here we are M upon EI diagram, and in this step we will calculate slope at point B. I am denoting it as theta B. So here is the equation to calculate theta B. Theta B is equal to minus area of M upon EI diagram between point B and A. Okay. So for calculating slope at B, we need to calculate area of all this 3M upon EI diagram. Okay, so area of this first M upon EI diagram considering point load only is equal to, this is triangle. So area of triangle is 1/2 PH. So it will be 1/2 base of this triangle is 4 meter and height of this triangle is 160 upon EI. Okay, so area of this first M upon EI diagram considering point load only is equal to 1/2 4 into 160 upon EI. Now, area of parabola. Area of parabola, as we discussed earlier, it is 1/3 BH. So it will be 1/3 base of this parabola is 4 meter and height of parabola is 160 upon EI. So area of this second M upon EI diagram considering downward UDL only, it is equal to 1/3 4 into 160 upon EI. Now, area of this third M upon EI diagram, which is considering upward UDL only. So, it is area of this triangle, this parabola. And area of parabola is 1/3 BH. Here, area of parabola means base of this parabola is 2 meter and height of this parabola is 40 upon EI. So here I am indicating plus sign because M upon EI is plus. Okay, and in this both M upon EI diagram are negative. So here I am indicating negative sign, and for this third M upon EI diagram it is positive. Okay, so area of third M upon EI diagram is 132 into 40 upon EI. So if I am calculating, I am getting theta B is equal to area of first M upon EI diagram. It is 320 upon EI. Second is 213.33 upon EI. And third, it is 26.66 upon EI. So if I solve, I am getting theta B is equal to 506.67 kilonewton into meter square, and converting it into Newton into mm square. So I am multiplying 506.67 with 10 raised to 9. Value of E and I, it is already given. So 2 into 10 raised to 5 and 5 into 10 raised to. So I am getting value of theta B is equal to 5.06 into 10 raised to minus 3 radian. So let's move to next step, step number 3. In step number 3, we will calculate deflection at point B, YB. So here is the equation to calculate YB. It is equal to minus moment of M upon EI diagram between point B and A about point B. Okay. So here we need to calculate moment of all this M upon EI diagram about point B. So moment of this first M upon EI diagram about point B is equal to area of this triangle into distance of CG of this triangle from point B. Now area of this first triangle we already calculated, it is 320 upon EI, and distance of CG of this triangle from point B is 2 by 3 into 4. Now moment of this second M upon EI diagram about point B. So it is parabola. So area of parabola we already calculated, it is 213.33 upon EI. And distance of CG of this parabola from point B is 3 by 4 into 4. Similarly, for this third M upon EI diagram, area of this third parabola is, we already calculated 26.66 upon EI. Okay, into distance of this parabola from point B is equal to 2 meter. 2 meter is the distance between B and C. Plus 3 by 4 into 2. 3 by 4 into 2 is the distance between CG of this parabola from point C. We are calculating moment of this parabola from point B. That's why I am adding 2 meter here. Okay. So if I calculated, I get YB is equal to 1400 kilonewton into meter cube by EI, and converting it into Newton into mm cube. So multiply 1400 with 10 raised to 12. Value of E and value of I, which is given, 2 into 10 raised to 5 and 5 into 10 raised to 8. So I am getting YB is equal to 14 mm. Here I am getting deflection positive. It means the beam is deflected in downward direction. Okay. This is end of this session. Thank you.